Everyone, this is Dr. Yuti. Now today we are going to find the half range sine series for f of x equals to x in 0 comma pi by 2 and f of x equals to pi minus x in pi by 2 comma pi. Also write this f of x equals to x, that is 0 comma pi by 2 and pi minus x in 0 comma pi by 2 comma pi. Okay. Now here find the half range sine series. Half range Fourier sine series. Okay. First of all, here given function is f of x equals to x in 0 comma pi by 2 and pi minus x in pi by 2 comma pi. The half range sine series of function f of x is given by f of x equals to sigma n equals to 1 to infinity bn sine n pi x by L, or otherwise read as f of x equals to summation over n equals to 1 to infinity bn sine n pi x by L. Okay. Next, here this is the Fourier half range sine series expansion. In this bn means Fourier constant. Now write the formula. What is the formula? In the half range sine Fourier series expansion of the constant bn, that equals to 2 by L integral of 0 to L f of x sine n pi x by L dx. Okay. Here L equals to pi. Why? Because here interval means pi, 0 to pi. Okay. L means pi. L equals to pi. Now substitute f of x equals to sigma n equals to 1 to infinity or summation over n equals to 1 to infinity bn sine nx. Okay. And bn equals to 2 by pi integral of 0 to pi f of x sine nx dx. This is the formula for the given interval 0 to pi about the half range sine Fourier series expansion constant bn. Okay. Now 2 by pi integral of 0 to pi by 2 x sine nx dx. Here f of x means x. The interval means 0 to pi by 2. So here write 2 by pi f of x split up into the given functions. Here x means 0 to pi by 2. Pi minus x means pi by 2 to pi. Okay. Now here write x sine nx dx 0 to pi by 2 plus pi by 2 to pi. Pi by 2 to pi. What is f of x here? Pi minus x. In the interval pi by 2 to pi, what is the function f of x here? Pi minus x. So write here pi minus x sine nx dx. Okay. Now 2 by pi x into integral of sine nx dx minus here using the integration uv formula, u into integral v dx minus integral of d by dx of u into integral of sine nx dx whole bracket into dx. Okay. Now substitute the limits 0 to pi by 2. Next of all, here assume that this is u and this is v. Now using the formula integration of uv. Okay. Now integral of here also using the formula integration uv. Assume that here pi minus x means u and sine nx means v. Okay. Now pi minus x into integral of sine nx, u into integral of v dx. Next of all, minus integral of d by dx of u. Here what is u? Pi minus x. Therefore, integral d by dx of pi minus x. Again integration v dx, that is sine nx dx into dx. After integration, substitute the limits pi by 2 to pi. Okay, now using the formula here, integration of uv dx, u into integral of v dx minus integration of d by dx of u integral v dx into dx. Okay, now 2 by pi. Here sine nx, integral of sine nx means minus cos nx by n. Again nx means n. Integration means write n denominator here. Here write x minus x cos nx by n. Next of all minus integral of d by dx, that is 1, sine nx, that is minus cos nx by n dx 0 to pi by 2. Next of all plus pi minus x into here sine nx, again sine nx means minus cos nx by n minus d by dx of pi minus x. Minus x means minus 1. Pi means constant. Okay, here again sine nx means minus cos nx by n into dx pi by 2 to pi. Next of all 2 by pi minus x cos nx by n minus into minus plus, again cos nx means sine nx by n. Already n is there, sine nx by n square 0 to pi by 2 plus minus of pi minus x, this is minus here, minus of pi minus x cos nx by n minus here cos nx means sine nx by n square, minus into minus plus into minus minus, again sine nx by n square pi by 2 to pi. Okay, 2 by pi into minus pi by 2 cos n pi by 2 by n. Next of all 0 sine n pi by 2 by n square. Now substitute 0 means this term will get 0. Next of all see here minus 0 into cos n into 0 by n plus sine n into 0 by n square. First of all substitute upper limit in this term and substitute lower limit in this term. Okay, next now here only substitute upper limit and lower limit. Here minus of upper limit means pi, so minus of pi minus pi cos n pi by n minus sin n pi by n square. Okay, here lower limit means pi by 2, so in place of x means pi by 2, here pi minus x is there, pi minus pi by 2 cos n pi by 2 by n, pi minus pi by 2 cos n pi by 2 by 2, sorry, cos n pi by 2 by n. Here also minus sin n pi by 2 by n square. Okay, now 2 by pi, this 2 by pi, here 2 by pi is there, 2 by pi into minus pi by 2n cos n pi by 2 minus pi by 2n cos n pi by 2. Next plus sin n pi by 2 by n square plus pi by 2n cos n pi by 2 plus sin n pi by 2 by n square. This is 2 pi minus pi, pi by 2. Pi by 2n minus into minus plus cos n pi by 2 plus sin n pi by 2 by n square. Okay, here in this term, first term, we'll get only this term. This is 0. And in the second term, we'll get only this term. This is 0. Okay, now 2 by n minus pi by 2n cos n pi by 2 plus sin n pi by 2 by n square plus pi by 2n cos n pi by 2 plus sin n pi by 2 by n square. Here sin n pi equals to 0. Sin n pi equals to 0. Here 2 by pi minus pi by 2n cos n pi by 2 cos n pi by 2 plus sin n pi by 2 by n square plus pi by 2n cos n pi by 2 plus sin n pi by 2 by n square. Okay, now 2 by pi into, here write, complete this term. Here 2 by pi into 2 sin n pi by 2 by n square. This is sin n pi by 2 by n square. Again plus sin n pi by 2 by n square. 2 sin n pi by 2 by n square. Okay, here cos n pi means minus 1. 4 cos n pi means sin n pi means 0. Here write in these two terms 2 sin n pi by 2 by n square 2 by pi into, here minus pi by 2 pi cos n pi by 2 by 2, next plus pi by 2 pi cos n pi by 2 gets cancels, only will get in these two terms. Adding the same term 2 times means here I 2 sin n pi by 2 by n square 2 by pi 4 by pi sin n pi by 2. Okay, 4 by pi n square sin n pi by 2. Bn equals to 4 by pi n square sin n pi by 2. On substituting Bn, where in equation 1 we get, that is here Fourier series expansion, half range sine Fourier series expansion, f of x equals to sigma n equals to 1 to infinity Bn sin n pi x by L. Now find out here the value of Fourier constant Bn in the half range sine series expansion. Substitute here, that is f of x equals to sigma n equals to 1 to infinity 4 by pi n square sin n pi by 2 sin n pi. Okay, thank you.